Welcome to the Tech Mechanic. Before we start, a quick reminder. This video is part of our Complete Solution Architecture playlist. In previous videos, we've already covered topics like shopping app architecture, SQL versus NoSQL, Redis, Elasticsearch, Kafka, RabbitMQ, API Gateway, authentication, OAuth 2.0, and monolith versus microservices, and many more. If you are watching this video for the first time, I highly recommend checking out those videos as well, because each topic builds on the previous one. Together, they form a complete roadmap from beginner to solution architect. Now let's learn event-driven architecture and why architects use it. Imagine you place an order on Amazon. Within seconds, your payment is processed, inventory is updated, an email confirmation arrives, reward points are added, analytics are updated, and your order appears in your history. Did one service perform all these tasks? Not at all. Instead, one simple event triggered many independent services to react. This architecture is called event-driven architecture, and today we'll learn it in the simplest way possible. An event is simply a notification that something important has happened in the system. It doesn't tell another service what to do, it simply announces a fact. For example, order created, payment completed, or customer registered. Other services decide whether they want to react to that event. In traditional communication, the order service directly calls the payment service, then waits. After payment succeeds, it calls inventory service, waits again, and finally calls notification service. Every service depends on the previous one. If one service is slow or unavailable, the entire workflow is delayed. In event-driven architecture, the order service doesn't call every service directly. Instead, it publishes an order-created event to an event bus such as Kafka. Any service interested in that event receives it independently. This removes tight dependencies and allows services to work in parallel. The service that creates an event is called the producer. Services that react to that event are called consumers. One producer can have many consumers, and consumers don't need to know anything about each other. This loose coupling is one of the biggest advantages of event-driven architecture. Let's use our shopping app. A customer places an order. The order service publishes an order-created event. The payment service starts payment processing. Inventory reserves stock. Notification sends a confirmation email. Analytics updates sales dashboards. Recommendation service learns about customer preferences. All of this happens independently and often in parallel. Architects choose event-driven architecture because it improves scalability and flexibility. New services can subscribe to existing events without changing the producer. If tomorrow the business wants a loyalty service, it simply subscribes to the order-created event. No changes are required in the order service. Although event-driven systems are powerful, they introduce new challenges. Events may arrive more than once, services must handle retries safely, events can arrive out of order, and debugging becomes more difficult because many services process events independently. Architects must plan for these scenarios from the beginning. Architects don't replace everything with events. If the customer needs an immediate response, REST APIs are usually the right choice. But if multiple services need to react independently or work can happen in the background, event-driven architecture is often the better solution. Let's summarize. An event represents something that happened. Producers publish events, consumers react to them, and an event bus delivers messages between them. This approach creates loosely coupled, scalable, and resilient systems used by companies like Amazon, Netflix, Uber, and LinkedIn. In our next video, we'll dive deeper into CQRS, where architects separate read and write operations to build highly scalable enterprise systems. Thank you for watching. Hit like and subscribe, and do not forget to click on bell icon.